Okay, I'll move to question 4 now. So let's read question 4. Question 4 here, they're saying, how much water would you add to 46.8 milliliters of a 1.93 molar sodium chloride solution to prepare 0.504 molar of sodium chloride solution? Okay, so here what is happening here, they are diluting the solution. Okay, so you can see that here we had a higher concentration here. Okay, but now they're saying how much water can we add to this solution in order to dilute that concentration to this value here. Okay, so here we use what we call as the dilution formula. I don't know if you guys have learned that already. Okay, you use what we call as the dilution formula. Okay, so that dilution formula is written as, where is the cardboard? Okay, so the dilution formula is given as the concentration before dilution, which will be represented as M1 multiplied by the V1, will be equals to, okay, the concentration after dilution multiplied by the volume after dilution. Okay, so this is the initial volume, the initial concentration, the final concentration, and the final what? Volume. So we're going to use this dilution formula here. Okay, so we're going to say what is our M1. Okay, so our M1 there will just be 1.93 molar. This will be our M1. And then our V1 will be the first volume that you can see on your question there, which was the 46.8 milliliters. Okay, and then the M2 will just be the final concentration, which was 0.504 molar. Okay, and then the final volume is what we don't know. Okay, is what we don't know. So how can we find this final volume? We just put these values into this formula here and solve for V2. So if we make V2 the subject to the formula there, it means I'm going to have M1 V1 divided by M2. So my M1 will be 9.3 multiplied by the volume, which is 46.8. And then I'm dividing all this by my M2, which is 0.504. Okay, so when I divide this, I get my final volume there. Okay, so what does this value give me? So you can punch on your calculator. Okay, so on my calculator here, it's showing me a 179 somewhere. So 179.21.2142, and then 85.7, and then the number goes on. Okay, so these are what? Milliliters. Okay, so this is the final volume. Okay, but it's not the amount of water that you can add. Remember, let me draw a picture. So if this was the solution here of sodium chloride there, and then it had a concentration of 1.93. Okay, so it already had a volume here of 46.8. Okay, but now that we've diluted it, okay, it means this volume is going to increase. Okay, if it was there, it means after diluting, after adding water, so let's add this water here, the blue one on top. Okay, after adding this water, the blue one here, we now have this value here, which is the 179 point whatever we have here. Okay, so how much water was added to this beaker, okay, to reach this volume here? So you're going to say water added, I'm just going to say WA here. Water added is equals to the final volume, which is 179 point, you can say 21 there, round it off to 2 decimal places, and then you can say minus 46.8. Okay, so this will be now the volume that was added for the water. Okay, so if you subtract these two, you're going to get a 132.41 milliliters. Okay, so how much water should be added for us to reach this volume? You have to add 132.41 milliliters. Okay, so this one here is the final answer. Okay, so use the dilution formula there. Okay, so those who have questions, you're free to ask. Otherwise, I'll go to question 5. Okay, so now what do we have on question 5? It's a very simple question on question 5. Everyone should get this one. Okay, so on question 5 there, we are dealing with the accuracy and the precision and the type of error that will affect the results. Okay, so let's read the question. So they're saying a laboratory instructor weighed an object 4 times and recorded the readings as 281.12, 280.37, 281.38, 281.03 and 281.01 respectively. And then they're saying the true value was 81.72 grams. Okay, now the question comes. So let's answer these ones together. So they're saying comment on the precision. Is it poor or good? You even explain why you're saying that. Is the precision poor or good? Anyone? Hello?
The precision is good. Me, I can say the precision is good because there is a consistency there in the numbers.
Yes, okay. Because all these values here, they are just close to each other. So the precision there is good. Okay, so your comment there should be, it's good. You even give the explanation. Don't just write good. Okay, and then B, they're saying comment on the accuracy. So is the accuracy good or poor there?
No.
Okay, yeah. So the accuracy there definitely will be very poor. Why? Because if I get the average of these numbers, so if you add this, add this, add this, and add this, and then you divide by 4 to find your average, okay? Your average will be somewhere at 280 something, okay? And that 280 something is way above the true value. So you're going to say here, the comment there is poor, okay? And then you give the explanation as I have said. So if you find the average from this, that average will be way above the true value. That will be the explanation there. And then even here, you give the explanation. And then C, they're saying which experimental error, if any, affected the measurements and give one justification. So which error there affected the results?
I can say systematic error.
Why are you saying systematic error?
Because they are in the same direction.
Yes, okay. So the deviation, okay, from the true value is in the same direction there. You can see that all the values that are deviated from the true value are above, okay? So meaning the direction there is the same, okay? But in a situation where we had the true value as 81.72, and then we had some values, maybe 72, and then we had some values, 281, okay? It means here, it will be random errors because we have a deviation in both directions. We have numbers that are less than this and numbers that are greater. But in this situation, we see that all these here are greater than the 81. Okay, so the systematic errors are the ones that are affected, and then you give the example that they're in one direction. The deviations from the true value, they are in one direction, or you can say all the measured value are above the what? The true value. So that's the explanation there. Okay, so we go to question 6, which is a very interesting question. Okay, so they're saying which, if either, has more sugar in it? A cup of tea with 1 lump of sugar or a whole cup of tea with 2 lumps of sugar? What can you say? Which one has more sugar in it? We don't have an idea there. Okay, maybe I ask like this. So if I get a cup that is half full and I put 1 spoon of sugar, and then I get another cup which is full, and then I put 2 spoons of sugar, okay? And those spoons of sugar, they are of equal amounts. Which one will be sweet? Which one will be more sweet if you drink?